Thank you for inviting me for PyCon Italy. And if you don't know what's Graceful Shutdown, you're a perfect audience. If you know, still, you will learn something new. Who am I? My name is Andrii. I'm originally from Ukraine. Currently, unfortunately, I live in Austria. Fortunately, not so bad. I'm software engineer from Dynatrace and tech evangelist. I like sport and other stuff. So just in case we are hiring, yeah, drop me a message or email and I will help you. Okay, so what is a graceful shutdown? Not many people, surprisingly, don't know about it, but it's okay. Recently, every app can be deployed using containers or maybe orchestration of containers, which makes this problem even more critical. So graceful shutdown is a process where a program or application is terminated in controlled manner, rather than like critically or abnormally. So for example, what does it mean? Before we're killing something, we can complete running tasks, we can close files, release resources, and etc. You will learn more. So today's agenda is pretty simple. We will see how to implement graceful shutdown inside your Python application. We will discuss some sync examples, which means synchronous code. We will discuss async examples, which are popular nowadays. And importantly, we will discuss how Kubernetes does graceful shutdown, so you know it. And we will talk a little bit about releasing because it's kind of connected. So, yeah, we all know development is hard. Especially cloud native application development is hard. If you run something on Kubernetes or on containers, it's not necessarily mean it's cloud native. To make it cloud native, we should do some hard stuff. So regarding this topic, I try to check different books. There is no like chapter, graceful shutdown. Yeah, this term is very software engineering or like make your app more reliable. And yeah, so if you try to Google it or find some books, it's pretty hard. Same as documentation. Okay, let's deep dive into coding. If I have time, I'm pretty sure I can try to show you some demos. I know doing demos during public talks is a bit risky, but I still love it. It just proves that it's not just a blah, blah, blah talk and I really did something. So, okay, you can say it's easy peasy. You just write a main function. It has like a, let's say, some job. You can just accept exception by keyboard interrupt when someone clicks Ctrl+C, log it, and yeah, finally release some resources. Easy peasy, why we need a talk. But it's not so easy as you think, because this keyboard interrupt is kind of works but does not work. Why? Because if we run this program, and I will try to send this kind of signal int, which is internally Python translate to, or like this keyboard interrupt translated to signal int. We will discuss a little bit more signals later. And yeah, it's kind of work because I just emulated Ctrl+C and that's kind of done. But the problem is that exception can occur in many places and not only in try except block. And if it occurs somewhere in the middle or in the beginning, we never accept it, we never do finally, and we just crash and we will lose like maybe important data. So that's why it's not a good idea in general to use this keyboard interrupt except, and better to try to kind of create signal handler. What is signal handler? It's yeah, standard library from Python where you can define your shutdown function, and then you can just kind of use it as a callback when signal received. So this is much better example, because now if we run it and if we try to kill it with another signal which is sig term, we will discuss it a little bit later, what's the difference between previous one, it will work, but previously it did not work, because if I send this signal, we'd never catch it and we just lose everything, even without exceptions. So yeah, and yeah, for example, if you just kill it, it's another problem that we do not catch it, so we killed, but this is okay. Why? And which signal we should care about? So in general, if you are not familiar with signals, you can just go to manual page, but usually we care only about 3 signals: sig term, sig hub, and sig kill. These only 3 we need to know right now, and sig int, therefore. Why? So what is signals? Signal is how operation system sends to the processes signaling that something is happening, for example, when it's decide to destroy process, and then we can catch it. The problem is that important observer can say, okay, but there is a big list, why we are not just using everything, and you're right, but there is no standard. So Nginx use termint, but when terminating something, or quit, or hub for reload. Docker use kill and sig term for gracefully stop something. Kubernetes does the same. I intentionally not put all other process management like UVcorn or GUIVcorn, etc. You can read about it without me. But there is a hell of these signals and how to handle it. Like how to handle it we just discussed, but which one is still unclear. That's why it's important that we need to kind of know and decide in advance what we want to, on which signals we want to react and how. And as I told you, better just register signal handlers. I have a little bit improved version, which now what it does, it just says, okay, let's focus only on these 3 signals, iteratively register it. Unfortunately, you have to register one by one. We register the same shutdown callback, and now you see we don't have except. So this callback, importantly, running in the main thread of the Python program, and when something happens on any line, we will react. So, for example, if outside signal comes, we will react. And proof of my words is now, if we run this example, it was too quick, and we try to send sig int or term or like hub. So like every signal has a numeric representation from my previous slide, but in majority of Linux-based systems you can just use this name. I found it just more kind of easy rather than putting here. I print the number of the signal. So for example, this is 2, 15, and 1. So you can also use it when you want it during debugging. Okay. Now let's do very short recap what we learned so far. I hope you learn. Try except keyboard interrupt is not enough. It doesn't cover all cases. We need to use proper signal handlers, and we should listen correct signals. So we just add the signal handler. Sounds like we are done, no? But no, we need to go a little bit deeper, a little bit. Let's define a problem from different perspective, because as a Python developer, usually you finish your job, you give it maybe someone, or like you deploy it, and it doesn't work. Why? Because, for example, on Kubernetes, there is like a pod, and inside pod we run container, and here is my small tiny Python application, and it introduced some complexity, because now it's not I am sending kill from terminal, Kubernetes does, and I can't control it, right? Okay. Kubernetes, when you did, okay, let's a question. Who knows what is Kubernetes? I know it's dumb question. Okay, cool. So we don't need to discuss it. So when you delete Kubernetes pod, what Kubernetes does, it's very simplified version because there are many steps. I intentionally remove it. But what it's important today is know that Kubernetes will send sig term, wait 30 seconds, by default. It's a graceful period of time. If we can't like stop the application or like stop the process, because under the hood Kubernetes is just like a few machines, nodes where we run processes, yes, using container runtime, but in the end of the day just a process is running somewhere on machine. So after 30 seconds, it will send sigkill signal. Again, someone probably saw I do not catch it in my handler. We will discuss it in a few seconds. Otherwise, you can override this termination graceful period, whatever, 5 or what. By default, it's 30 seconds. And then Kubernetes will wait shorter and then sends kill. However, you should remember that Kubernetes not designed for like, you should not extend it. So like, if you decide to put like 1 hour, whatever, it's not a good idea in general. So 30 seconds is already a very huge window, and we should clean up our resources much faster. There is a good article where guys suggested 20% of time we should kind of reserve for Kubernetes and other stuff to not clash with our internal cleanup. So ideally, you should use 30 seconds default and like 25 seconds for cleanup and 5 seconds reserved for something else. So this is a dumb example when you can kind of make it smaller and test, not production ready. Okay, if you think you don't need it, you're very much mistaken, because even if you don't, Kubernetes deletes pods all the time. Even if you not notice, all the time Kubernetes does reconciling between like desired state and actual state, and it's tried to scale up, scale down. If you're using autoscalers, or even if you don't, it will still, when you update something or do releases, it's infinitely kind of or remove pods or create new pods. So it's inevitable to skip this kind of graceful shutdown. You have to think about it. Otherwise, you just kind of stateless application which does nothing, return static text, and you don't care about state. Have another demo, still on slides. What I did, I built my Docker file. I will share it, it's pretty dumb. And I created a pod, and I tried to delete a pod. You see, I don't send any signals. I just create a pod, check that it's running, and I try delete pod. So very simple example. And when I try to grab logs, it's the same application, and now we can see that Kubernetes sends this sig term, and after, if it's not succeeded, in my case it's succeeded, so it's never send kill, so it's only sig term, and yeah, and it works. in my example, it was more like synchronous code, right? Like, I mean, main loop, everything linear, but we live in asynchronous world. As this joke about like, I can do everything in async, and now we have two problems, right? Especially this one is very much interesting. So, but graceful shutdown of async code is much simpler, or not much simpler, as exactly the same as synchronous. Why? It just different that you need to create an event loop, and same strategy. You have try except finally you have important task, and on finally now you have something to clean up. Before was super dumb example which print something, but now we really close the loop, and in a main block we really run infinite loop. And if we try to run it, yeah, it's same, it works. You can send Control C or int or whatever, it stops, it cleanups. Everyone happy. Same problem as with synchronous code. Because we don't have a signal handler, we will fail on other signals rather than the one I just showed you. So to fix it, I hope you can see it, we can implement a signal handler. We will find all running tasks using loop. We will cancel every task, and then we will stop the loop. And in the main, yeah, this part is new. And in the main, we remove catch because it's not useless, but it's not optimal. And we register every signal inside our loop, and it will react on the three most important, like most common use signals. And we are good. Now a question for a beer for today. Question: what will happen if I try to subscribe on SigKill? Any ideas? Go ahead. You know answer. Okay, any other ideas? No. Any other thoughts? Except you, if you try, you know. If you know, you know. No Googling, just a beer from me. Any beer. Okay. Yeah, I mean, if you try to do it, so like as I did, and my friend from the audience, same out of curiosity, like why not? There's like list. Yeah, it will not work. Like you can't just do it. And I like, invalid argument, I tried to Google it, and like, what the fuck, I did everything correct, right? It's like a signal, I put it there. Yeah, but very intentional reader, read the man pages. That's why I like documentation, not LLMs. I told it all my colleagues and friends, read manuals, and it's written. The signal SigKill cannot be caught, blocked, or ignored. Why? It's very important because this SigKill for killing processes, we don't clean up anything on it. We clean up only on sig term or maybe other signals, but never on these two. It's lesson you have to learn. And second curious someone, like maybe my friend knows the answer. There is no, yeah, it's already answered. We don't have time, unfortunately. So if you try to emulate it with kubectl, like kubectl has this delete pod with like graceful period 0, force true, like no way, not today. Why? Because it's kind of a bug or like feature. There is an issue, you can't do it. So why it's important or why it matters to anyone? It matters because you would like to test your system what will happen in failure scenarios, right? Like you can't just implement it and trust by heart. You want to try kill something and see how it behaves. Otherwise, you're not sure if your implementation is right. So, final thoughts about releasing. This one you will like it. we will talk about stop signals. Stop signal is a Docker file feature, not the movie. Like you can define the stop signal for your container to use by container runtime when you want to delete your, stop your application. So it's in case if you don't like SIG term, you can change it. You can change it when you run something, but on production, usually we don't use Docker. And then you can stop it with your custom signal. Why it's important, sometimes you have tricky cases, so you need to distinguish different codes. Yeah, I need 1 more minute. So last but not least, Kubernetes 1.33 has a feature. You need to enable feature flag. It's article from like 10 days ago, so super fresh. So you can define on pod level stop signal, which is very neat in my opinion. I will post slides, don't worry. About releases, why it's important. Releases are inevitable. We do releases, we can't stop. When we release something, we need to stop, and then we need to start. There are a few options how to release in general. We can discuss it during beer, but I will quickly show you. One is zero downtime deployments, which means you will try to ideally deploy new version so user will never notice it. Option B is Kubernetes rollout updates, well known. Like Kubernetes will run new version in parallel with old version. The side effect, if you have database, there is a problem because old version running Python model for database version 1 and here version 2 will just fail. Blue-green deployments, we don't have time. An interesting one you can read, I will put an article or we can talk. There is a nice term rainbow deployment, which is kind of green-blue deployment, but more. No time. Instead of update your, so important idea for Graceful Shutdown, instead of update, you can just create new version in parallel that's about rainbow deployment. This is a conclusion. Okay, conclusion. Graceful Shutdown is not easy. It's inevitable because we always need to do releases. Know your app and your infrastructure before you start developing it, especially during designing phase. No surprises. Yeah, read the docs and test everything. Yeah, there are a bunch of links. You can find me here, and here's questions, and here's slides. So you can just scan it.
Thank you so much. Now I know what mean Graceful
Now you know.
Yeah.
see, you learn something new. So
yeah, of course.
I lived my day not like without any sense. Cool.
We have 2 questions. What are some sort of real scenarios example where handling such shutdown is crucial?
Yeah, there are many. Like imagine you have like whatever async IO application which does some inserts to your database, and user in the middle. You probably all of us did like online shopping, and you in the middle of your payment gateway, and developers decided to release. So like we need to either finish all transactions or roll back it, so you will start from where you left. So you can't just abnormally kill everything because you will have semi-working state of your database. Or imagine you have a message in the queue and you have a workers, and it grabs a message, it's in the middle of processing it, and we are redeploying. So we are redeploying workers as well, and we cancel all messages. So in this case, we need to put message back to the queue. So after release, another worker can grab it and finish processing. There are many examples. Yeah.
Okay. The other one. in real life, what are the problems if I don't manage the Graceful Shutdown? Do you have some story to share with us?
Yeah, it's even easier. I mean, it's related to previous one. If you don't care about it, it can be just memory leak. You will have lots of zombie processes. So uh, your database, if your database has a connection pool, and if it's limited, and if you don't properly close connection, it means new deployment will start new processes and will like try to connect to database, and there is no enough connections because you did not close previous ones, so it's kind of no good. Yeah.
Some other question from the panel? Okay. Okay, thank you, Andrii. Okay.